Welcome to Volume 1 of the Enterprise DevOps and Platform Engineering Study course. This 20-minute lesson covers Linux and platform fundamentals, enterprise Linux administration, networking, storage. The goal is to build an interview-ready mental model, connect architecture with implementation, and show how a senior engineer diagnoses production failures. Take notes on the control flow, security boundary, failure modes, and validation commands in every section. The video is a guided overview of the complete handbook, so use the detailed document and labs for deeper practice after watching. The module on Enterprise Linux architecture and lab design establishes the following ideas. Enterprise Linux architecture from hardware to user-facing services. A production Linux platform is not only an operating system installation. It is a controlled service stack consisting of firmware, hardware, the kernel, device drivers, storage and network subsystems, identity controls, service management, application runtimes, monitoring. Senior engineers reason across these layers rather than treating incidents as isolated commands. Initial platform baseline: create 2 Linux virtual machines on an isolated virtual network. Configure static host names and record IP addresses. Add a non-root administrative user and grant controlled sudo access. Configure SSH key authentication between the client and server. Collect a baseline report into or var or tmp or baseline date.txt. Snapshot both machines and document the restore procedure. Create a change log containing objective, commands, validation, and rollback. The module on boot process, grub2, kernel, and initramps establishes the following idea. Linux boot sequence and service activation flow. The boot process begins before Linux executes. Firmware initializes hardware and selects a boot entry. grub2 loads the selected kernel and initramps. The kernel initializes core subsystems, discovers devices, and mounts a temporary root from the initramps. It then switches to the real root file system and starts PID1, normally systemd. Kernel and bootloader inspection confirm whether the failure occurs before grub, during kernel loading, during initramps, or after systemd starts. Use the console to select a previous known good kernel. In an interview, explain the design choice, the most likely failure mode, the evidence you would collect, and the safest mitigation before making a permanent correction. The module on package management and software repositories establishes the following ideas. Package managers maintain software payloads, dependencies. Production patching should be repository-driven, repeatable, and auditable. Avoid copying and manage binaries into system paths unless the application has a controlled packaging and lifecycle process. The module on systemd service management establishes the following ideas. Figure 4 systemd units, dependencies, and activation. Systemd is the service manager and PID1 on most enterprise distributions. It starts units according to dependencies in target state, supervises processes, and integrates with logging, resource controls, sockets, paths, and timer, service and boot analysis, or etc., or systemd or system or example API.service validate and activate the unit, create, or etc., or systemd or system or example API.service.d or override.conf. From a senior engineering perspective, connect these mechanisms to availability, security, scalability, change management, and evidence-led troubleshooting. In an interview, explain the design choice, the most likely failure mode, the evidence you would collect, and the safest mitigation before making a permanent correction. The module on Journal D, our syslog and audit evidence establishes the following ideas. Operational debugging depends on trustworthy timestamps and complete evidence. Systemd Journal D collects structured metadata including unit, key ID, UID, boot ID and priority. Our syslog can route logs to files or central collectors, audit record security relevant events that ordinary application logs may not capture. High-value journal commands, persistent journal deconfiguration, activate persistent storage, audit evidence collection. The module on users, groups, sudo, and PAM establishes the following ideas. Identity operations combine account data, authentication, authorization. Local files may be replaced or supplemented by LDAP, Active Directory, SSSD, or other identity providers, but the diagnostic model remains the same. User and group administration, least privilege pseudo example from a senior engineering perspective. Connect these mechanisms to availability, security, scalability, change management, and in an interview, explain the design choice, the most likely failure mode, the evidence you would collect, and the safest mitigation before making a permanent correction. SSH, firewall and mandatory access control. The module on permissions, ACLs, and Linux capabilities establishes the following idea. Linux discretionary access control begins with ownership and mode bits. ACLs add named user and group entries. Capabilities split selected root privileges into smaller units. These controls operate before or alongside mandatory access control such as SELinux or AppArmor. Permission inspection and auditing collaborative directory. ACLs allow a non-root binary to bind to a privileged port. The module on OpenSSH and remote administration establishes the following ideas. OpenSSH is a core administrative control plane. Production configuration should minimize password exposure, restrict privileged login, use modern keys, provide auditable access, and preserve a verified rollback path. Generate, deploy, and debug in SSH key. OpenSSH hardening dropping. Validate before closing the current session. Confirm DNS resolution and route to the server. Test TCP connectivity to the SSH port. Check server listener and firewall policy. Use SSH BBB to identify negotiation, host key, or authentication. Validate file ownership and permissions on the home directory, .ssh directory, and authorize keys. Inspect SSHD logs and SELinux for AppArmor denials. Confirm allowed users or allowed groups. Match blocks and identity provider. In an interview, explain the design choice, the most likely failure mode, the evidence you would collect, and the safest mitigation before making a permanent correction. Networking and DNS. The module on disk partitioning and file systems establishes the following ideas. Storage changes have a high blast radius. Always map the device, file system, mount point, application owner, backup state, and rollback method before modifying. Device names may change across reboots. Persistent identifiers such as UUIDs or LVM paths are safer, or etc. or FSTAB. Create and mount an XFS file system from a senior engineering perspective. Connect these mechanisms to availability, security, scalability, change management, and evidence. In an interview, explain the design choice, the most likely failure mode, the evidence you would collect, and the safest mitigation before making a permanent correction. File systems, LVM, RID, and swap. The module on LVM, RID, multipath, and swap establishes the following ideas. Logical and physical layers in an enterprise storage stack. Create an LVM-backed file system. LVM snapshots provide a point-in-time block view but are not a complete backup strategy. Snapshot capacity must cover change block. A full snapshot becomes invalid. Applications may require queuing or database native backup procedures for consistent. Create and remove a short-lived snapshot RID and SAN path inspection. The module on C groups and Linux namespaces establishes the following ideas. Namespaces isolate views of system resources. C groups account for and limit resource consumption. Containers combine these primitives with file system images, capabilities. Secomp and understanding the host primitives is essential for diagnosing container and Kubernetes behavior later. From a senior engineering perspective, connect these mechanisms to availability, security, scalability, change management. In an interview, explain the design choice, the most likely failure mode, the evidence you would collect, and the safest mitigation before making a permanent correction. The module on Network Manager, Routing, Bonding, and VLAN establishes the following ideas. Network Manager provides a persistent connection profile model on many modern distributions. Production network changes should be staged from console or out-of-band access because an incorrect address, RHEL, VLAN, or bond configuration can immediately remove remote access. Create a static connection profile active backup bond with VLAN 120. The module on DNS server and client operations establishes the following ideas. DNS problems often appear as application failures, repository failures, or authentic separate name resolution from network connectivity and application transfer. A successful ping by IP does not prove that DNS works. A successful DNS lookup does not prove that the service port is reachable. The module on firewall, tables, and network security establishes the following ideas. Firewall is a policy management layer that commonly programs tables. Directly mixing unmanaged NFT rules with firewall can cause confusion unless the ownership model is deliberate. The safe debugging approach is to inspect the active rule set and packet path, not to stop the firewall. Zone-based firewall management: inspect and understand an table's rule set, confirm the application is listening on the expected local address and port. Confirm routing and return path. Inspect active zones, sources, interfaces, and capture packets before and after the expected decision point. Use NFT monitor trace for a controlled test where appropriate. Check cloud security groups, network ACLs, and upstream firewall separately. Apply the narrowest required rule and verify persistence after reload. In an interview, explain the design choice, the most likely failure mode, the evidence you would collect, and the safest mitigation before making a permanent correction. Web, proxy, file and database service. The module on SELinux and AppArmor establishes the following ideas. DSC and SELinux access checks mandatory access control constraints processes even when traditional file permissions allow access. SELinux uses labels and policy rules. AppArmor primarily uses path-based profile. A secure troubleshooting method identifies the intended access, confirms application configuration, and then adjusts context. Boolean. Persistent SELinux changes AppArmor profile lifecycle. The module on cron and system timers establishes the following ideas. Schedule jobs execute with a reduced environment and no interactive terminal. Use absolute paths, controlled environment files, explicit time zones, blocking and for service-oriented platforms. System timers provide dependency handling, misrun behavior, and journal validate the schedule and job. The module on MariaDB platform operations establishes the following ideas. This chapter focuses on operating the database service as a platform component rather than database development. Production databases require application consistent backup, tested recovery, access control, least privilege application account logical backup, and restore database operational checks. From a senior engineering perspective, connect these mechanisms to availability, security, scalability, change management. In an interview, explain the design choice, the most likely failure mode, the evidence you would collect, and the safest mitigation before making a permanent correction. The module on performance analysis and kernel tuning establishes the following ideas. Evidence-driven performance triage. Performance engineering begins with a user-visible symptom and an agreed baseline. Avoid tuning random syscode values. Measure workload, saturation, latency, error. Optimize the actual constraint and verify that the change improves the business metric without creating a new bottleneck. Performance evidence collection. Example only. Validate against workload and distribution guidance. The module on Linux security and server hardening establishes the following ideas. Hardening is a lifecycle, secure build, identity control, patching, service minimization, network policy, mandatory access control, audit. A checklist is useful, but each control must be tied to threat model and application requirements. Time and cryptographic policy checks. From a senior engineering perspective, connect these mechanisms to availability, security, scalability, change management. In an interview, explain the design choice, the most likely failure mode, the evidence you would collect, and the safest mitigation before making a permanent correction. The module on production bash scripting establishes the following ideas. Bash is effective for orchestration and platform glue, but production scripts require the same engineering discipline as application code. Define inputs, strict error handling, logging, idempotency, concurrency control, tests and quote variable expansions unless deliberate word splitting or globbing is required. Use arrays for lists. Do not build commands through unsafe string concatenation. Use mktemp for temporary files and remove them in a trap. Never place secrets in command line arguments, logs, or shell tracing. Use print rather than echo for untrusted or escape-sensitive data. Validate paths before destructive operations and include dry run support. Return meaningful non-zero exit codes and expose machine-readable output where useful. The module on monitoring, backup, and operational readiness establishes the following ideas. A platform is production-ready only when operators can detect failure, understand impact, recover service, and prove the recovery. Monitoring, alerting, logging, backups, runbooks, and ownership are part of the implementation, not post-deployment. Define recovery point objective and recovery time objective with the service owner. Backup configuration, service data, certificates, and recovery. Use application consistent procedures for databases and transactions. Keep copies in a separate failure domain. Consider immutability and offline protection. Encrypt backups and control restoration. Monitor job completion, backup age, object count, size anomalies, and verification. Perform scheduled restore exercises and document actual recovery. In an interview, explain the design choice, the most likely failure mode, the evidence you would collect, and the safest mitigation before making a permanent correction. You have completed the guided overview of Volume 1, Linux and Platform Fundamentals. The next step is practical repetition. Recreate the architecture without looking at the handbook, implement the supplied labs, inject at least 3 failures, and document symptoms, evidence, root cause, mitigation, and prevention for interview preparation. Answer each scenario aloud using a structured sequence. Clarify impact. Establish scope. Check recent changes. Collect evidence. Form and test hypotheses. Mitigate safely. That senior level performance is demonstrated not by memorizing commands, but by making reliable decisions under uncertainty.